Hello everyone, welcome. In this video we are going to calculate the standard deviation and variance. We are going to the standard deviation and variance. So we have, let's say we have an example with the ages of people, of some children. And to calculate standard deviation, we are supposed to know a formula. This formula, standard deviation, is given as sigma. Sigma is going to be equal to the square root of this, the summation from I equals to 1 to n of x minus x bar, all divided by 2, all squared, divided by n minus 1. So this is a formula to calculate sigma, to calculate the standard deviation. Now when you have the standard deviation, we now come back. When you have the standard, in order to calculate the standard deviation, you are going to use this particular formula. So we need to calculate the mean to have the standard deviation. So now let's see. Again, the first thing we are going to ask to the user is to printf. We are going to first printf. So printf, we say enter the total number of variables. So enter the total number of variables. You tap till you tap to go to the center. Now when you enter the total number of variables here, it's going to enter here. Now as it's going to enter, we are now going to create another. So this is printf. So after that, you're going to create another. You're going to scan f and take the value from the screen. So we have percentage %d here, comma, and replacing the address of a variable. We have to declare here, say n equals to 0, declare this variable and place it inside the address. The next thing to ask the user is printf. So from this printf, we now ask him to enter all the variables below. So now when I say this, you have to go to the next line, shift tab away from the margin. Now you go down, you scan f, and you are going to store now these values in an array. So before you store the values in an array, I first need to create an array here. So an array needs to be created here. So that array, I'm going to say is of float type. So the array is of float type, and I call it variable. And now place a size of n, which is the total number of variables as they enter. Now you have print this. I'm going to scan now this. I'm going to paste. You see that now the variable is of type floating type, so I'm going to use a %f, use comma, then I'm going to place it in the address of variable here. This as such, address of variable. When I place in the address of variable, I then have to place the total number n here. So I go to the next time. So I have printf this scanf voila. So I have all this. So this will enable you to scan the values. So before I will scan the values, I need to create a printf here for chronology in our work. So I will go to the next line, and then I will tab it. Then I will tab again. I place here variable, and I place 2 dots such that when it enters, scanf as such. So now you are going to enter the different values. Now the first thing to put in mind is to calculate the mean. How should you calculate the mean? So to calculate the mean is going to be due to the addition of all the values that you have entered, all divided by n. So this is how you are going to calculate the mean. So mean here will be the mean calculation. So since somebody can enter even 100 terms, I don't want to focalize myself on doing one addition with another addition. So I'm going to use loops. Loops is going to help me to do multiple addition at times. So I'm going to use the while loop, and every time you use loops, you must make sure that you must have a counter. So I'll initialize a counter I here, I equals to 0. So and this I will call it a counter. So every time I want to use loop, you must initialize counters, and then our counter is 0. So I place here I is less than, when I is less than n, then I'm going to go down and do this. Now what happens is that I want to sum up all the values inside that has been entered by the user. So I'm going to create a new variable called sum of floating type. So you have float here and then sum here. Sum, I initialize the value to 0. So I'll create a new variable sum of floating type. I place now sum here is equals to sum plus, now what will I do? I do variable is variable. I need to arrange this float of n. This is variable into n. It is initialized here. Now I come here, I put variable as such here. When I have variable here as such, now the next thing to do, I have sum this. What will happen is that every time when I go on the next time, I have I equals to I plus 1 as such. Now what will happen is that I equals 0. In this case, the n number of terms is going to be 8. So 0 is less than 8 is going to enter. Sum is first having an initial value of 0. Then you have here is not n but instead I. So you take the value of 0, then the value enter, it will sum and then go. Here it will give you the total sum of value. Now on the down line, I'm going to initialize a new variable called the mean. So I'm going to call it mean. I initialize it as a floating type, declare as floating type, and I say it's mean. I initialize it with the value 0. Now when I've declared the mean, I will now say here that the mean is equals to, or I come back again, I say it will be the total sum divided by n. So n that is inside, I place a semicolon. So that will be the value of mean. So I can even printf the value of the mean so that it should be shown to the user. So printf the mean is 2 dot. Now I come here, \n \t here. The mean is this. Then I go to the other line. Then I place here, in order to have the location, I place the %f here because I've stored mean in floating type. Then I place comma the value of mean here. Now this is the mean. So now for me to calculate, now the next part of my procedure is to calculate the variance. Now to calculate the variance, I'm going to sum up all the values. So let's come back again here. You see that the variance is normally the standard deviation squared. So variance is summation from I equals to 1 to n of x minus x bar all squared divided by n minus 1. So I'll come back to my code. What I will do is that I will take each value that has been stored, then I will subtract it by the mean, and then I will square it. When I square it, and then I will try after squaring it, I will divide it by n minus 1. Now the function square is stored in a preprocessor called, so the function square is called in a preprocessor, so I will say include here is stored in a preprocessor math.h. So I need to include math.h in order for me to have it. Now you know that the values of the preprocessors here are not stored as being floating points. They are stored mostly as being doubles. So anything that I'm going to use in this processor must be of type double. So let's go again. You have variance. I want to do the summation of all the values. So what I will do in order to have the variance is that I'll first try to create a new array. So that new array, I'm going to call it will be of a double type, not of floating type, because I'm going to use square on it. So that array will be of double type and will be called sum of let's say sum variables, sum square. So we call it sum square. I'll first compile here, see that there are some errors which are going to be shown. So I have sum squared, then I'll place now, we'll say that it contains the value of this n, total number of terms. Then I'm going to now initialize each value. Now I'm going to put each of the terms squared now inside them. So what will I do? I will use first a while loop. So now for me to use a while loop, I need first to initialize back the counter to 1 to 0. So I 0 here, initialize back, I place the while loop as such, then I come, I have while here, so I say while I is less than n, then you come out, enter into next loop. What will I do? I will now say that sum into this sum square here in bracket I will be equals to this sum squared in bracket I will be equals to sum. So there is first no need to when reasoning, there is no need of putting this new integer type, so that will be only taking much more memory space in the machine. So it can be done on one line. So I'll remove again this array, and then I'll create now, so I'll close first it here, this two, this one, no, this is C, place curly bracket. Now you have this. Now when you have yi is less than n here, so what I can do here is to take a value sum. So initially here you have the sum here, so I'm going to take a new value sum square. Now sum square, I'm going to initialize the sum square here as being double, or as being, let's first start with floating type, but you need to note that math.h is using variables which are of type double. So if an error comes, we know where to change, where you have to change the variables, because it's supposed to contain in doubles. So you add in here sum square. So here is sum square. We initialize the value to 0. I will come down here, say sum square is equals to, replace again sum square, this one here, sum square plus, now we use our function in mathematics, because this function is stored, this function squared is going to be stored in math.h. So there is a need for you to declare include math.h for you to use this square function I'm going to use now. So the preprocessor math.h contain the steps by step which is going to show to the compiler GNU.gcc how to involve with the square root of the number you're going to place in. So to write square, we just have to have sqrt and place in bracket. We write the value that we want to be squared. In this case, I want that each variable which is squared. So I'll start from variable 1 and then I go to the last variable. So it's variable into square bracket. I place I. When I come out, I place minus the mean. So it's as such here. So I come and place the semicolon. So this will be the sum squared. It will give me the sum squared here. When I have the sum squared, I now go down, I place I is equals to I plus 1. So what will this line do? Every time, starting from here, you have I equals to 0. So I equals 0 is in this equation. You see that it will be less than n in this equation here. So I equals 0 will be less than 9. So you have 0 less than 9. It's going to enter into the loop. Sum 0 is first the value. So you have I0 enters. You take the first variable, which is 12, minus its mean, and you square it. You add it plus 0 to have the first sum. Then you add it, come with 1 up here. You are going to now have the second term plus the sum you initially had to have the next sum and all that. So this is going to give you this sum. So when you are calculating, you're going to calculating with this step here. With this step here, this line 40 is going to give you this sum in the numerator. Now, when you have that sum on the numerator, you can say we can create a new variable of type float. We first start with type float called variance. So that new variable of type variance, we initialize it with value 0. So variance now, come and say here now that the variance which has been given up there will be equals to, the variance is equals to now this sum squared, replace sum squared here, now divided by this sum squared divided by, we see that variance, when to calculate the variance, you need to do this sum squared divided by n minus 1. So I come back again to my function and I do in bracket, this is sum squared, I'll place it in bracket. Then I'll divide by n minus 1, semicolon. So you have this as variance. Now, when you have the variance now, you can now say directly that standard deviation. So I'm going to create another variable of floating type called standard. No, it's more a standard deviation. Now, since you have this one variable standard deviation of 0, just come down here. Down come here and write standard. It shows up to you. Standard deviation will be equals to. Now, we initially said that inside the preprocessor math.h, there's also going to be another function which is being stored there, and that function is the square root. So for you to, this is square here. In order for you to write square, you are writing square root. So in order to square this function, I will instead use the function power. So my power here, is taking two values. The first value is the one I want to square, and the next one is the power to which I'm squaring. So I'll say 2 as such. So this is, and this other one is used for square root. So standard deviation will be the square root as such of the variance. I write variance inside as such. Now semicolon. Now I can come down and print f. I say the variance is 2 dots. The variance is, I place now in percentage f here, comma, and then I write variance. And I come out, Place semicolon, write again another printf. Here I'll write the standard deviation is 2 dot, I come and write %f, then I come with a comma and I write now the value of standard deviation here. I put semicolon. So now you have this and you have this. Now what will happen is that I am now going to shift it 1 line below or 2 line below, and then when I shift it 2 line below, no, the 1 line below instead, and I tab it, I come here, shift it 1 line below, I tab it, I come back here, I want to shift it 2 lines, so I'm going to shift again another line below. So this is the code for writing. So I compile. So there are many errors that are shown up to me. Let's say we have error 17. So on 17 they say token. So I have to place a semicolon here. On line 20 they say expected before float. So line 20 we come here, this expected before float. This is because we didn't place a semicolon on this line. We place semicolon here. Line 26 we see this, they say variable undeclared because it's not well spelled. So line 26, so we see here that's variable undeclared. So we need first to declare this variable. It has been forgotten to declare the variable. So to declare a variable, we need to declare a variable here of floating type, and we write variable, and we should put again n here. So this is to declare the variables, but variable has been declared here. So maybe it's because the spelling was not identical. So in order to take this, we are going to instead place a value I here. So and now lastly, we have forgotten to place a loop in order to take all the values inside. So we need another while loop to create here. We're going to create another while loop up here. We say I is less than n, then use this braces, then remove this one, and then cut this, and then we come and paste it here, such that the computer can take our values n number of times. So we have this as such. So this is our program. Now compile again. This is because of this. We compile again, and then no problem is shown us to us. So we run. Enter the total number of variables. So the total number of variables, let's say it's 5. The all variable below, so I have to change. So I have to say enter all the variables below as such. All the variables of your statistic measurement. So this is it. So we compile, no error is shown, then we run. So the program opens. Total number, let's say, is 5. So enter all the variables statistic measurement below. I want to enter, let's say, 2, 3, 13, and 45. So 5 is 1, 2, 3, 4, and then I enter the next one, 7. So you see the mean is, so an error has been shown. the mean wasn't well calculated. So you need to see the error. So the error has been shown because when you come out of this loop, you see that when it comes out here, I will enter, and then it will come out, and it gives the value of I to be it will give the value of I to be 7 if it is 8 here. You give a value of 8 here. So we first need to reinitialize the value of I here to 0, such that it stack back the counting for you to have the sum and have the mean here. So when you have this, you compile and then you run. So now let's say you have 5 variables. You enter one variable, 1 3 4 2 5. So we have 1 3 4 2 5 are all the values. So the error was showing because of the double type. Initially I told you that the variables of which are these functions which are stored in math.h are using variables of type double. So you need to declare all these variables in type double except those of integers. You need to declare all the floating values of type double. When you declare all the floating value of type double, now when you want to enter the values inside the double type, you instead use LF and not F. That's why errors were being shown to me. So you see, instead use, in this case of double, use LF and not F only. Instead, in order to bring out the value of the double, use LF. So now when you use all this, you can compile and run. Now when you compile and run, you have this. So let's say you want to enter 5 numbers. Let's say 1 3 4 2 and 5. So these are the 5 numbers. So you see here that the mean is given to you as 3.00 and the variance 2.5 and the standard deviation is given as this. Now we can try with the example shown to us above here. So compare and run. So let's take example has 8 number of values, 8 values above. Now the variables are going to be 12. They are going to be 13, 8, 9, 12, 12, 13, and 9. So we have all this. Now since we have all this, now we can press that and see. You see that the mean here is going to be 11, the variance is going to be 4, and the standard deviation is going to be 2.00. So from here we've seen how to write a program which will help us to calculate the mean, the standard deviation, and variance of our code. So hope you are going to like this video and subscribe to this channel, Science Video Makers. Thanks for your kind attention.